Hello everyone. So we want to do an example on saturation. That's a practice example. I specifically chose this example. This is a little bit harder than other examples, so that's why I chose this example to work on. So let's see what type of problem we are dealing with. So basically we have a core sample which is brought to laboratory for analysis. 70 grams of the core sample were placed in a mercury pump and found to have 0.71 cc of gas volume. So for this specific experiment, we have basically 70 grams of the sample, right? And that, let me see. So that 70 gram basically lead to 0.71 cc of gas, right? Okay, cool. That's the first information we have. The second information is given to us is an 80 gram of the core sample was placed in a retort and found to contain 4.5 cc of oil. So 80 gram of that sample, core sample, basically they use retort, and as you know, retort measure the volume of oil and gas, oil and water directly. So the volume of oil they discovered was 4.5 cc, and the volume of water was 2.88 cc. A piece of original sample weighing 105 gram was placed in a pycnometer. It's a device basically that measures the solid volume and density, and found to have the bulk volume of 45.7. So basically 105 grams of the solid weighs 105 gram, right? Sorry, that's the weight is 105. The volume of the bulk sample is basically 45.7 cc, right? And we know the density of the water given to us, and also we know the API gravity of the oil inside the sample, right? All right, so we need to find the porosity, water saturation, oil saturation, gas saturation, and lithology of the sample based on the given information, right? Okay, so one part that is confusing about this problem is basically we have separate amounts of solid, and one is 70 gram, one is 80 gram, one is 105 gram, and they did different type of experiments. They measure different properties. But what you need to do is basically to you need you need to basically put all these in the same consistent amount. So for example, your gas volume is 0.71 cc, right? But that's only for 70 gram of the sample. How about if you had 80 grams? How about if you have 105 gram? How much gas you would have? So you can see basically also for this one, the volume of oil is 4.5 cc. The volume of water is 2.8 cc, but that's only for 80 grams of the sample, right? How can you basically make all these measurements into one correct, consistent reference volume? Okay, that's what you need to do first. Okay, you can choose any reference volume. Okay, uh, probably 100 gram is one easy basically amount that you want to use as a reference basically amount. So the goal is basically, for example, to find the volume of the gas for 100 gram sample, right? So remember, basically you can say that, okay, you can say that if 70 grams of the sample have, oh god, 70 gram of the sample basically have 0.71 cc gas, right? 100 gram of the sample contains how much volume of the gas, right? Pretty simple basically calculation. It's basically you can do the cross multiply, right? And if you do the cross multiply here, then you can say, okay, 0.71 multiplied by basically 100 divided by 70 grams. That gives you 1.014 cc. Right? So if you have 100 grams of the sample, you will have 1.014 cc of the gas. If you have 70 grams of the sample, you have 0.71 cc of the gas. So the goal is basically make all these in this consistently with the same amount of solid that we have. We have to do this for oil. So we have 4.5 cc, and that was measured with 80 grams of the sample. So then we do this. We want to see how much oil would be in 100 grams of the sample, which results in 5.63 cc's, right? We want to do this for water as well. So that's basically 45.7 divided by 105 grams, that's cc, right? Multiplied by 100 grams. So we want to see if we have 45.7 cc of water in 105 gram of the sample, how much water would be in a 100 gram sample. So that's 43.52 cc. So these are based on a 100 gram sample, these volumes, right? Next thing we want to do is basically to calculate how much grain volume, if we can calculate how much grain volume we have, or the matrix volume. Then we can use it to calculate the pore volume and eventually to calculate the porosity, which is the first part in this problem, right? So we can also say that the total weight of the matrix, if we have a 100 gram sample, right? That's what the reference weight was, right? We have a 100 gram sample, then how much of this weight, 100 gram is the total weight of the rock grains and also the fluids. How much of this weight is only the grains? So we have to subtract the weight of the fluids from the total weight, which is 100 grams in this case, right? How do we calculate the weight of the oil? Yes, you simply basically multiply the oil density by volume of oil, and then you subtract the water density multiplied by volume of the water, right? So this is the weight of the oil, this is the weight of the water, right? Okay, so let me delete this and I put the numbers in, right? So we have 5.63 volume of oil here in a 100 gram sample, and the density is 0.85. You know how we get the density, right? This is the API gravity. API gravity, right? That is equal to 141.5 divided by gamma oil minus 131.5. Gamma oil is also equal to density of the oil divided by density of water, right? So if you put 35 in this equation and put basically the density of the water in here to be equal to 1 gram per cc, then you get the density of the oil to be 0.85, okay? And then this minus 3.5 multiplied by 1. All right. Well, no, not it shouldn't be 3.5, right? This should be the volume of the water that in a 100 gram sample, which is basically I miscalculated here, I assume. Sorry, I did a mistake here. How much volume of water we had was basically 2.8 cc's, right? And multiplied by that, that would be 3.5 cc. I did it here correctly. That was 3.5 cc, correct, yeah. So that would be basically this, right? And you can calculate the total weight of the matrix. This is the matrix volume, sorry, the matrix weight, and that is 33.37 cc, right? And then you can calculate the pore volume, right, which is the sum of your basically gas volume, oil volume, and the water volume. So 1.014 plus 5.63 plus 3.5. You can see these volumes at the top: volume of gas, volume of oil, and volume of water. Right. So your total pore volume is 10.14 cc. Right. So therefore your porosity is 10.14 divided by bulk volume. What is our bulk volume? See that bulk volume here? That's 45.7 cc, but that's for 105 grams of the sample. So you need to calculate equivalent bulk volume for 100 grams of the sample, right? And that is equal to what? 45.7 multiplied by 100 divided by 105, right? Make sure you don't mix it up. This is for 100. You have to use this reference. You can't just combine all these with different weights. Okay, so that results in 23.31% porosity. So that's the first part that we have to solve, right? All right, cool. So second part is asking about the water saturation. I think that the rest is pretty straightforward. So water saturation is simply pore volume by, water volume by pore volume, right? So we had 3.5 cc of water divided by 10.14. That's our pore volume, which we calculate in the top. And that gives us what? 34.5%. Oil saturation, volume of oil divided by pore volume. That is 5.63. 10.14. That is equal to 55.5%. Gas saturation is 1.014 divided by 10.14 is 10%. So that's the gas saturation. And finally, we can find the density of the matrix. Why do we need that? We need it because we want to calculate the, or is that part of, yeah, we want to find the lithology, right? So the density of the matrix is basically the weight of the matrix, right? And which was 90. We just calculated it at the top. Yeah, this weight is also wrong. I mixed up. I wrote the solutions in another paper, and when trying to refer to that, I make mistakes. Sorry about that. So 91.75 grams, right? Okay, sorry about that. So the density of the matrix is what? Is basically mass of the matrix or weight of the matrix. Either way, you can basically write it either way, divided by volume of matrix, right? The mass or the weight we already calculated, 91.71. The volume we haven't calculated, right? But it's pretty simple. It's the bulk volume minus pore volume, right? So 91.71. The bulk volume we calculated it 45. Well, this would result in I think I did calculated it here, 4352. So that's 4352 cc's. So that's 4352 minus your pore volume. So pore volume is 10.14. So the resultant density 2.75 gram per cc, right? So now you can refer to basically the tables and check basically what lithology we have, and that's up to you. Go and check the table and see which one basically have this density.